I wanted to make a video about the difference between precision and accuracy, because a lot of times students are confused about those terms, and even people who understand the difference sometimes use them interchangeably. They don't mean exactly the same thing, even though they sometimes go together. I already made a video to go with section 1.5 in the note packet, and some others on how to calculate average, standard deviation, and percent error. I'll post these links in the description below. I didn't want to make a video that used a target to show precision and accuracy. Having that target makes it seem like you know the right answer, and a lot of times the whole reason you're doing an experiment is because you don't know the right answer and you're trying to figure it out. So I thought about that saying, for someone who can't aim very well, they might be told, "You couldn't hit the side of a barn." And I thought that would illustrate what I'm trying to say. I couldn't draw a barn, so we're pretending this is the side of a barn and it has this mural painted on it. And we're going to have some people shooting at the side of this barn. Or if you prefer to think of something else, it can be throwing darts or water balloons or spitting watermelon seeds. Your choice. Let's have 3 people aiming and hitting the side of the barn, person A, B, and C. Now the thing about precision is that you do not have to know what each person was aiming for in order to tell which one is more precise. A precise measurement is one that is close to other measurements of the same thing. If you measure something several times and the measurements are close to each other, you have precise measurements. You can tell which set is most precise using your eyeball here, but if you want to calculate and quantify precision, you would use standard deviation. With standard deviation, you calculate the average measurement, and the formula is based on the distance of each measurement from that average. We'll use this orange center point to represent the average. If we drew lines from this spot to each of the original data points, measured those lines, and squared each of those measurements, and then added those up, that's what we do for the start of the standard deviation calculation. Then we take that sum and divide by 1 less than the number of measurements, in this case 4, and finally take the square root of that result. That would be the standard deviation. The calculation is shown better in my other video, but the point is that a set of measurements with long lines will give you a bigger number than a set of measurements where the lines are shorter. Ideally, you want the standard deviation to be as small as possible. The smaller the standard deviation, the better the precision. The standard deviation does not tell you how accurate something is. However, seeing precise measurements can increase your confidence that you are accurate or close to the true answer. With these 3 people, just looking at their groupings and not knowing what they were aiming for, you might guess that person B with the most precise data set is more skillful and probably was aiming for that apple in the upper left and got pretty close. However, it's possible that there's a problem with what that person was doing and that person consistently made the same mistake over and over. It would be surprising, but it's possible that you find out the person was really aiming at the other apple over to the right. This brings us to accuracy. Accuracy has to do with how close you are getting to the true or accepted value. If there's no accepted value, if the true value is unknown, you will not be able to determine the accuracy. If we are seeing this barn after the people have left, we would just go with our best guess that person B was most accurate just because those spots have the best precision. In order to truly determine the accuracy, we would need to ask the people what they were aiming for, the true value in this case. We'll show that with a green dot. Then we would take the average and measure a line from the average to that spot that they were aiming for. The person with the shortest line is the winner for the most accurate. In this case, we would just take the shortest measurement, maybe in centimeters, but a lot of times in our data we would express the distance from the true value as a percent, the percent error. For this barn contest, all these people are doing the same thing, so comparing centimeter measurements directly works just fine. Being off by 1 centimeter means the same thing for all 3 of these people. We can compare it directly. But in other cases, saying that you are off by 1 centimeter might mean something different. If you're building a fence that's 75 meters long, 7,500 centimeters, being off by 1 centimeter is not a big deal. If you're building a jewelry box that's 25 centimeters long, being off by 1 centimeter is not good. 1 centimeter is only about 0.01% of the fence, but 1 centimeter is 4% of the length of the jewelry box. You're going to notice that. So it's useful to express your error as a percent. And remember that smaller numbers are better when it comes to error. The smaller the percent error, the better the accuracy. So if B we're aiming for the left upper apple and C we're aiming for the lower apple, then B would be more accurate. However, let's go to the surprising case where B was actually aiming for the right-hand apple and C was aiming for the corn ear. In that case, C would have been more accurate. So if the most precise set of points is not the most accurate, it's likely that there is a systematic error, an error that keeps happening the same way every time. For example, maybe person B is not accounting for the strong wind in the area. If that person figures out that the shots keep falling several centimeters to the left, the person can adjust where he or she is aiming and fix the problem. Or maybe there isn't wind, but the person is using the sight on a rifle, and that has to be adjusted slightly and will fix the problem. This is why we like to see precise results, even if they're not accurate. A lot of times the accuracy can be fixed by calibration or by figuring out the reason that all the data points are being skewed to one side of the expected results. Then if we figure it out, we can fix it. It's usually harder to fix something that is not precise. So it's going to take longer for person C to practice and get better. Or maybe they'll have to switch from watermelon seeds to darts or something. In lab, if you want more precise measurements, you might have to change the way you're taking the measurements or the type of equipment you're using. This example I've shown is very rare for someone to have results that are all over the place but still end up with good accuracy. The orange center dot is very close to the target, the corn ear. Once in a while I see a student with mistakes all over their lab report, and somehow the average they get is really close to what it was supposed to be, even though each individual result was really far. Like this person did not get close to the corn ear with any of the shots, but the average happens to be very close. So technically they are the most accurate, but in this case I would say it's time to put down the darts and go buy a lottery ticket. I just want to point out a couple more things about precision and accuracy. Since accuracy is telling how far from the true value you are, you can measure your accuracy and calculate your percent error with only one data point. You take the distance of that 1 point from the true value and express it as a percent. If you have a group of measurements, you can use the average, but if you only have one measurement, you can still do it with that one. However, you cannot calculate precision with only one measurement. Remember, precision is a measurement of consistency, and you can't do that with just 1 point. So if a fourth person, person D, came up and fired one shot or one watermelon seed, you could not judge that person's precision. But if you knew what they were aiming for, you could determine the accuracy. So for precision, you need a group of measurements, but you don't need to know the true value. For accuracy, you do need to know the true value, but you don't need a group of measurements. Let's put a summary up here. Precision is how close measurements are to each other. Accuracy is how close the measurements are to the true value. For precision, you need a group of measurements. Accuracy, you can calculate with just one. For precision, you do not need to know the true value, but for accuracy, you do need a true or accepted value. Precision is measured with a standard deviation. Better precision would be a smaller standard deviation. Accuracy is measured with percent error, so better accuracy would give you smaller percent error. If you have good precision but your accuracy is off, you can look for the source of error and fix it. If you happen to have good accuracy but bad precision, then that's just luck. Hope you keep getting lucky. I hope this video was helpful. Thanks for watching.